Oceans cover 70% of the Earth's surface and contain 90% of the Earth's biosphere. Presently, only 1/5 of the world's seafloor has been mapped. Compare this to mapping of our neighbouring planet Mars of 70%. There's much to be discovered in the ocean deep. The Portuguese waters are no exception. With the Azores archipelago and the Madeira Islands, Portugal's territory is the largest in the European Union and will claim 4 million square kilometres. That's the size of the Indian subcontinent. As yet, we have no deep-sea continuous monitoring system in place. EMSO-PT stands for the European Multidisciplinary Seafloor and Water Column Observatory, Portugal, and was established in 2017. As a research infrastructure, EMSO Portugal has several components. However, the main objective is to have a deep-sea observatory in Portuguese waters. To complement the Seafloor Observatory, there's a Water Column Observatory operating in a similar capacity, and it's this equipment that we were testing. Off the coast of Olhão, the Water Column Profiler was launched. The profiler is equipped with a set of sensors that takes measurements down to 150 meters water depth. The profiler runs along a cable measuring the water column properties. Once it reaches the bottom of the cable, it returns back to the surface to start all over again. The profiler is an ingenious type of technology as it relies on the motion of the ocean for the inertia of the profiler, and so it doesn't have to rely on batteries in order to move, as with other marine equipment. Along its descent, the CTD sensor measures conductivity, a measure of salinity, temperature and depth. It provides information about the physical properties of the seawater, allowing scientists to understand the distribution and variation of water temperature, salinity and density along the water column and identifying ocean currents. The remaining sensors, chlorophyll A, turbidity and dissolved oxygen, provide important information about primary productivity. This data is particularly important for scientists, as satellite data can only capture down to 10 meters depth, while species proliferate at much deeper depths and go unnoticed. It's also these data sets that help fill in the missing gaps for computer modelers. The water column sampling complements the Deep Sea Observatory. The EGIM, or EMSO Generic Instrument Module, operates as a fixed seabed station and has a set of sensors that continuously monitor the ocean properties as well as seismic activity. The EGIM records the physical water properties, allowing scientists to identify which of the deep water masses are influencing the site. Dissolved oxygen and carbon dioxide are also monitored and can signal important changes to the health of the oceans through understanding fluxes in the carbon cycle and alkalinity. The turbidity and current sensors monitor the presence and movement of sediment. Even the smallest mobilization of sediment can, for example, tell scientists about submarine slope failures in the vicinity. Large-scale events, such as landslides, have gone as far as causing tsunamis in the past, and therefore this information is vital. Acoustic sensors can also pick up whale sounds and give us a unique insight into their migratory patterns. The Cádiz Observatory is one of a network of deep-sea observatories in the European Union. EMSO Portugal forms part of the pan-European infrastructure EMSO ERIC. This is a significant step forward and will bring Portugal into the 21st century of ocean research.